Thanks a lot, Monsi and the organizing committee for the invitation. Really glad to be here. And thanks a lot to you guys for taking the time to come to this session. So I'm just the messenger today, but to be honest, a lot of people within PIC, and as Jake and Joel mentioned, outside of PIC have been part of this investigation of this very interesting case. So, you know, there are people from our nutrition team, genetic team, production team that have been very active part on this investigation. Just as a disclosure, in case you're busy, have meetings or something, the cause of gilt silent estrus has not been determined yet, right? So if you're waiting for the answer and the cure, well, that we don't know that yet. So what I want to do today, and I have to thank my boss and the leadership team for letting us to transparently share everything we know since the very beginning of the outbreak, is to share with you guys what we've done, what we've seen, and what we're doing next, and using the power, the brain power of this room. If you have ideas on what could be causing this, help out, and we'll be happy to try anything else at this time. So one of the initial cases, or the initial case that we started working on, was in the spring of 2018. We started working with a multiplier that was recently stocked, new farm, and they complained, the concern was the gilts and the P1 sows that were weaned, just the first turn of that farm, were not cycling. That was the comment, the complaint at that time. Again, it was a recently stocked farm, so we thought, well, let's go there, let's look at health, right? Maybe it's not stable enough and things are unstable, or new crews, new teams, right? So let's look at performance or management, see what they do, how they expose the gilts, how they check for heat and all that. So we started with health. That's what we do in my team. So we took 60 samples. We included animals that were cycling, gilts and sows, and animals that were not cycling or affected gilts per the farm. And we tested for agents that we believe that could have an impact on reproduction. So PCV2, parvo, lepto. At that time was when the PCV3 PCR was included in the PCV2s, and there was some discussion about PCV3 relevance, so we included PCV3 testing in that sample. As you can see, this farm, and especially for being a new farm, pretty stable for those agents, mostly negative for PCR in all those agents. We necropsied 4 animals just to start, 2 affected animals and 2 non-affected animals, and submitted samples and look at macroscopic lesions, and then submitted samples to the D lab. And in summary, to make it short, there wasn't anything significant about those animals. So no signs of inflammation in those animals, nothing really interesting to look at, and then we didn't find any specific agents associated with the reproductive tissues of those animals. So the conclusion from that first investigation was that there wasn't anything evident on the infectious side or the management side that would tell us why that was happening in that farm. And that triggered a lot of work. We did 2 things. One, we agreed with the affected flow to go to slaughter and do some slaughter checks and evaluate macroscopically the organs, the reproductive tract of those gilts. And in summary, what we observed was that out of about 250 gilts from 3 different systems or flows, 76% of them had large follicles or CLs. So most of them were cycling, right? And we observe about 6% of cysts, about 0.8% of uterine abnormalities. We don't know if this is a cause and a consequence, but the tracts of the non-cycling gilts were lighter than the gilts that were cycling. That could be a consequence of not having activity in those animals. And again, the samples that we harvested those in the slaughter plant, took them to the diagnostic lab floor, did the macroscopic lesion, all the reproductive evaluation, and then histopathology on those. We did not find any evidence of inflammation in those organs. At the same time, our production team with the affected flows went to those farms, the GDUs, and understand more exposure, environment, management in those farms, and what are they doing, what are they reporting, what are they seeing for heat. And we learned that most of those gilts were showing, as Jake and Joel said before, some signs of estrus. Swollen volvas, discharges, etc. But consistently what they failed to share or to show was standing. The ultimate sign to decide when to breed a gilt. So those two things changed the dynamic of what we were doing, and from non-cycling we call this a failure to express normal behavior of estrus on those gilts, and that's where we started calling that silent estrus. One interesting comment is that there isn't anything else in those gilts that will tell you that's going to fail. So you can tell that the smallest one or one clinical sign will make them different than the cohorts, teammates that are having or having that issue. So we said, well, we have to organize this epidemiologic investigation. We have to start looking at what farms are affected and what not. Do we need a case definition? And as you would imagine, to establish a case definition on a subjective parameter like this one is tough. But we got together with a group of practitioners and asked for their advice and what they were seeing in the field and what is expected to be normal. And we proposed a case definition of we have to have 3 consecutive weeks of less than 80% of your gilts expressing normal full estrus after at least 6 weeks of exposure to the boar to call that a case. And with that, we can start organizing and see what is a case, what is a control. One point here is, and one of the challenges for the investigation is that, again, estrus expression is variable, right? Even in a normal farm, I consider this a normal farm, you have variation group by group. This could be a weekly group or a monthly group, just your lot of gilt. And this is the percentage of gilts in that group. In a good farm, if you have everything perfect, personnel, feed, facilities, environment, health, you're going to hit 95% of them, but you still lose 5% of those gilts that you won't breed. In other cases, without any issue, you're going to still breed in 80, 85 to 90%. So we put that line there, and we start talking a lot about this term. It's called gilt utilization. It's pretty much the percentage of gilts that you end breeding over the total group of gilts that were selected or susceptible to HNS in the farm. And that way we can organize a little bit the search. The other challenge is that most farms were not capturing this information on a routine basis. And it's very easy to understand, because if you look at how a GDU works, you get your gilts, you start to breed them, but you don't waste or you don't take them to slaughter after you finish that group. You keep them, try to breed them, and they get overlapped with the next group. So it's hard to keep the integrity of the group if you're not purposely looking for that. So that was another limitation. I think the industry has got much better in the last year to track this parameter. So what did we observe once we went out and check on all the flows that we work with and see, okay, who has the problem, who's reporting that. As Jake reported before, we observed a lot of variability, both in one farm, so you have very good groups that you breed pretty much 90-95% of the gilts, and then you have 2 or 3 weeks where you breed 65, 70, 75% only. Then they come back to normal, and then they went back and do bad. And then that makes it very confusing, because you say, oh, I vaccinated them for something, or I changed the ventilation pattern here. So it's very confusing because you have that variability by farm. The other finding was that in an implicated multiplier, you had customers that had awesome performance. They bred 90-some% of the gilts, never complained. This here is a lot of gilts, thousands of gilts. And then you had underneath some customers that were reporting the issue. This case, sorry that I didn't explain the legend, but green will be good. They don't have any report. They breed more than 90%. Yellow could be either a farm that is implicated but they haven't seen the issue, or the farm that got problems before but recovered. And red is the case definition that we just mentioned. Okay, so the variability depending on receiving farm is also there. We have multipliers where a lot of customers are happy and you have few customers reporting, or the other way around. The next observation is that there seems to be clustering of cases. Some flows are more affected. So if you think about our genetic pyramid, this is all the multipliers within PIC. We believe that about 10% of the farms will have some implication with this case, and they seem to be clustered in one group. We have not seen more cases, new cases after we did that initial search. We have been looking at all those flows, implicated flows, but we have not seen more. So if you're wondering, is it spreading or growing? At this point, we have very limited impact of those flows. It was mentioned before, but I want to make the point that teammates or pen mates of those same gilts that have been affected and they don't express full heat, if they stand and breathe normally, they will have normal conception rate, firing rate, litter size in the same GDUs. And the other observation is what has been referred to a couple times. If you switch sources, same genetics, different multiplier that hasn't had reports, you had these numbers and then light switch. You change the source and then all of a sudden those gilts raised in the same GDUs with the same health, same protocol, same environment, they are just going to breathe, express full heat just fine. So we start thinking about, okay, what could be causing this interesting, awkward presentation? So if you look about reproductive performance or development, and I don't pretend I'm going to talk about that with Dr. Rob in the room, but there's reproductive development happens all the way from gestation in utero, early lactation, so most ovarian development happens in gestation, most uterine development happens in early lactation, and then we know that the way or the life of that gilt and GDU determines her ability to perform later as a mature gilt. So everything that we do to them in the GDU will affect them. And if you think about it, so nutrition of the sow or the gilt itself will affect, genetics of course, then environment once she's born, the dam effect until at least lactation, any infectious agent could affect that gilt. Because of the geographies and the flows and the affiliations of those systems, I'm not saying that it's not a toxic effect or management, environment, or nutrition, but it'll be hard to make the case that in all those places they have the same common factor. It might make it worse, but probably it's not the primary cause. We don't know yet. We'll keep looking. It might be something generic in all those places, but that's why we're focusing on those two items here, pretty much infectious and genetics for the next few minutes. So the challenge again is that you have a potential exposure very early in life, in utero or early lactation, and then you have the expression of that when the gilt is 30 to 36 weeks of age. So it's a challenge to look at everything that remotely happening after the exposure. So let's take a look about genetic origin. And I got a couple of slides from our genetic team to summarize what they've done. First, what they did was, okay, let's take a look at all the affected farms and the non-affected farms and see if there are differences in terms of the boars that were used, the boar stats that were used, any genetic lines, the percentage of the genetic components of all those, pedigrees, families, and all that. So they evaluated all of that in those farms, and so far they haven't seen a pattern. So gilts that go across the system will perform differently depending on the destination. Then the genetic trends on all reproductive traits that they follow, they monitor, have been favorable. We looked at the top of the pyramid, so all the elite farms in the top of the pyramid, and we've looked at conception rate, firing rate, litter size, gilt utilization. So to give you an example, our GMs run somewhere between 96 and 98% on a normal basis of gilts being bred in those pure animals at that level. We've reviewed the source of the boars. So what about the boar stat? What are the boar stats that are supplying these farms? So we took a look at all that. And then an important thing is that if you look at genetic pyramid and maternal production, because we want maximum diversity, I mean as many families as we can in a farm, and we want high performance or genetic improvement, we want to have all our families in all the farms. So these same boars of the affected farms are used globally in a lot of other farms, and we haven't seen the problem. Then we have the ability now, in the last 5 years, we have collected genome sequence, whole genome sequences from all the elite animals. So we have thousands of genomes that we can evaluate. So we have been testing candidate genes. Somebody comes with the idea, there is a condition in humans that could cause this, or this is a condition that we should look at. So we've been trying to evaluate that, and still on some things ongoing, but every time that we've been able to identify a gene of the genome, we have been testing the populations, and what they are looking for is diversity or variation, right? If they see that in one population you see that gene and you don't see in other animals, that's interesting. So let's start looking at association. So far, those genes that we have tested don't show variation. It means that they are the same in all the population that we test. We have going back to those multipliers and check that they are actually an F1 made of landrace and large white, and we have a double check with genetics, their pedigree, and see if they are actually the daughter of that specific line. And as I said before, we have used those boards globally, and so far in any other country we haven't got that report, so that's for us is important. So far they have been close to that. They say, hey, we'll test anything, we'll keep testing, it's our responsibility. So they've been very open at looking at crazy ideas that we bring to them. Let's go on the infection side. So there are a number of viruses and bacteria that you could associate either to reproductive disease or that could potentially affect the development, the central nervous system or the reproductive system in those animals. So we have looked at that all the way from the source farm, gestation, and early lactation to the growth of that gilt. So we start, well, let's prioritize what would be the agents that we should look at. And that's all the way from conception. So the first thing was, okay, let's take a look at semen and see if the semen that goes to those affected farms is different to a control farm. So we went to one of the board stats that is supplying some of these farms and took 10 samples of extended semen, and then we went to a control farm that hasn't seen the problem and took 10 extended semen samples of 5 boards included in each pool. And did bacterial culture. We did targeted PCR for mycoplasmas, for chlamydias, for other agents, and we did next generation sequencing. So we say, well, let's sequence whatever is in that semen sample and see what we get. To make it short, and I can share more details and dendrograms with you as needed, but so far with all these 3 techniques, we haven't been able to find an agent that is present in one, absent in the other one, that you could associate to this condition. So we've been looking at that, but so far it doesn't look like. And the other component that was in the previous slide is that this borstat, and they also deliver semen to farms that have been normal and don't have any report underneath those multipliers. So it's a little bit difficult to explain that origin of potential semen contamination. One of the discussions that we had, or we were talking about, was chlamydia. Chlamydia suis, is that a possibility as one of those agents? So we looked at chlamydia, and there's not much in swine that has been reported. So we got the fortune to meet with Dr. Bernard Kallenbach from Auburn University, and he's an expert, a global expert in poultry and cattle or bovine chlamydia. And he was, kind enough to work with us and try to learn as much as possible in swine because there's not much reported. So what we did was, after a lot of discussions and kind of looking at what we had, going to a farm that had recovered, that farm that had issues in the past that now was performing well, a farm that was for us a control, so a farm that never had any farms reporting cases underneath or themselves, a farm, a multiplier that had problems, a farm that was getting gilts from this farm that never reported issues, and another farm that was getting gilts from this farm that was seeing issues. So these were 2 cases, 2 controls, and 1 so-so farm. We went and at each age, 3, 9, 15, 21, and 29 weeks of age, we tested 20 vaginal swabs in each one. And we wanted to understand 3 things. 1, the prevalence. How many positives or the incidence? How many positives out of the total? 2, the bacterial load. Because chlamydia is everywhere, so we want to understand who has more. And then 3, the genetic diversity of those chlamydia in those farms. So I won't bore you with all the numbers, but you can see here that in terms of proportion of positives, we have different percentages there. We'll see that in a graph right now. But there isn't much difference in terms of this is a positive number of positives compared to are they affected or not. And then underneath you have the log, the number of bacteria that they had in each sample. And then I'll show you guys that in a graph too. There isn't much correlation between the amount of bacteria and the expression of this condition. We went to 20 gilts that had normal estrus and to 20 gilts that had silent estrus and check, are they different? Do they have more chlamydia or not? And we went to 20 sows pre-feral and see what was the infectious dynamics of chlamydia. So just to summarize that table, we saw differences in age. So in most farms, this is pretty consistent. This is a summary of all farms. They get infected somewhere in the nursery, they all get infected with high loads, and then they start declining. They mount an immune response, they decline the number of positives and the bacterial load. And then we also find differences in farms. So yes, they are different in each farm, but at different levels. So for example, this affected farm was pretty high, but this affected farm was one of the lowest. This OK farm was here, and this farm without cases was here. So at this point, we didn't find any correlation between prevalence or incidence, number of positives, and the bacterial load for chlamydia. Then we looked at the genetic diversity. So what strains do we have in those flows? And these are the farm A, B, and C clusters. So this is a MLST of the most conserved genes of chlamydia that will help us to understand evolution. Are they different or not? And what we found was that it was a good tool to sort them out and make understand the difference between those. They cluster pretty nicely together and within farm. But if you can tell from here, all these affected and non-affected farms cluster all together and very differently to any other isolates that we found before in Asia, Europe, or North America. So, speculating, it'll be a long shot to say that this minor change that happened here that barely separates them within farms will mean a phenotypic difference in those animals. So in other words, the researchers said they are the same. They have a lot of variation, they change a lot, but in short, they are the same chlamydia that you have in the affected farms and the non-affected farms. In summary, chlamydia is everywhere. Pretty much if you test, you'll find it. We didn't find any other chlamydia, like an accidental chlamydia that will come from poultry or from cattle. There was no difference in terms of incidence and bacterial load. The gilts get infected in lactation and early nursery, and then they recover. There is no correlation between the genetic diversity and those animals, so we could not establish a connection between the presence or the difference of chlamydia and the expression of this condition. Other one that we looked at was PCV2. So at PIC, we really didn't do much on endemic agents before, other than dealing with the cases. If you have a case, you have to get a diagnosis and then share sequences, diagnostics, and all that. We decided because of this to start a project called PIC Endemic, where we want to understand all the agents or the most relevant agents that we have in our farms. So we started sequencing PCV2. Look here, the red ones will be cases. The black ones will be controls, and the blue ones are just reference from the lab, just to have an idea there. And this is PCV2D, as in Denmark, and then we have our A's and B's and our E's here. So as you can see from here, there is a lot of D, as in the industry. We find some PCV2D in our multipliers, in the farms, in customer farms that we look for. Most of the silent estrus cases fall into that group. But we also have a lot of non-affected farms sharing that same type of PCV2. So in short, yes, most affected farms are here, but we also have a lot of farms that are not affected within that cluster. So we couldn't establish a connection with PCV2D. It's interesting for us and has given us a lot of information to act on this one, but not necessarily on the silent estrus condition. PCV2D, now a discussion that has been more recent. We didn't have much information, so we went and checked all our flows and also historic samples that we had banked in the D labs. And as you can tell here, we have cases in all distributions. There's about 3.8% difference in ORF2 in PCV3 cases. We had cases from 2008 that were positive in non-affected farms. So we have a lot of overlapping between affected and non-affected farms showing different isolates or sequences of PCV3 in that sense. So because of the distribution of those genotypes, because of the timing of those genotypes, because of the sequences, we could not establish a connection with silent estrus. It would have been awesome if we say, yes, we find that one and we have it, or we don't find it. No, we didn't find that. We haven't seen a case like this morning was reported, or Emily Byers reported several months ago, on mummies or aborts or some mortality. All these, or most of these, were very high CTs that we actually had to do an amplification step to get enough material to sequence. So this is just, let's call it active surveillance. We go into healthy farms trying to get PCV3 out of those farms. So we couldn't make an association yet. We stay open, and now we're sequencing every PCV2 and PCV3 strain that we get. Just to close here, yeah, that's why I said that we'll try anything that you guys think about, because we've tried crazy things, right? This is a test on the olfactory sense. People thought about, are there gilts smelling the boar? So we got in collaboration with Texas Tech University, experts in olfactory sense of other species, and tested if the gilts were able to smell first. And the conclusion of the preliminary study is that yes, the gilts can smell. They use bananas for the test. The gilts can smell, affected or not affected. The gilts can smell the boar, so they can smell pheromones. There might be some differences there, but it's still too soon. But in general, they can smell the boar. And then the next step is just to understand a little bit that better. But so far, that has come down in our differential list because they really can detect that. Finally, just to lead on the next presentation, Dr. Knox will talk about that in detail, but we started some pilot study on the hormone level or hormone profile, and as you can tell, there is a difference in the amount of estradiol at heat, at estrus, in the affected animals lower than in the non-affected animals that is higher. We had a lot of variation in estrus, mainly because of timing of ovulation, so that triggered the next study that you're going to see later. So interesting. We don't know if it is a cause of a consequence, because if the gilt is not really expressing full estrus, maybe that follicular development is not going to be producing as much estradiol. So just to close, it is a complex case because of the subjective outcome or the case definition, because of the timing of exposure and outcome. Our objective from the very beginning has been to mitigate or minimize the dissemination of that. So even if we don't know the cause, can we contain it? Can we eliminate or not add new sources, not affect new farms on that? We are openly looking for ideas to continue to identify the source of this problem, and we are investing time, resources, and a lot of collaboration with very smart people on that, trying to find that. And we will continue to transparently share, communicate everything we learn. As Jake and Joel mentioned before, this has been a complicated case that we've been collaborating with others. So in summary, the cause of silent estrus in gilts has not been determined yet, but a lot of research is still happening. Most affected gilts cycle but fail to express normal estrus behavior. Silent estrus is defined by that 3 consecutive weeks of 80% or less of gilts standing after 6 weeks of overexposure. There is a lot of variation between animals and groups and receiving farms there. The cases are concentrated in what we call the 10% or less of our farms in the multiplication pyramid. Cohort gilts that express normal heat, they breed well, they have good conception following in those same environments. Any work that we've done haven't yield linkage or connection with genetics, or we haven't identified an infectious agent that is causing the condition. So with that, I'm sure that this is not complete, so I apologize, but just adding the people that have worked with us, the institutions, the vet clinics, the academic institutions that have worked in this case, has been a phenomenal effort to try and to understand this and solve it. So if you have any questions, thanks for your attention.